All right, this is just an audio test. Mic check, 2, 1, 2. All right. So greetings, scholars. Greetings, YouTube. Beautiful mind here. And let's see. So we are continuing our journey through chapter 2 for this College Algebra 1 at Morris Brown College on set theory. And we're working on section 2.3, Venn diagrams and set operations. Sorry. So some objectives here. We like to understand the meaning of a universal set, understand the basic ideas of a Venn diagram, use Venn diagrams to visualize relationships between two sets, find the complement of a set, find the intersection of two sets, find the union of two sets, perform operations with sets, determine sets involving set operations from a Venn diagram, understand the meaning of and or, and use the formula for the cardinality of A union B. So universal sets and Venn diagrams. The universal set is a general set that contains all elements under discussion. So John Venn from 1843 to 1923 created Venn diagrams to show the visual relationship among sets. Universal set is represented by a rectangle. Subsets within the universal set are depicted by circles or sometimes ovals or other shapes. So for example, I use the Venn diagram to determine each of the following sets. Okay, what's the universal set? Looks like we have what? Square, triangle, $, M, and 5. Okay. What's the set A? The set A is going to be the square with the triangle. And then the set of elements in U that are not in A are going to be $, M, and 5. All right, and we see all of that listed here. Okay. So disjoint sets, two sets that have no elements in common, okay? And then the proper subsets, all elements of set A are elements of set B, all right? So proper means that one set is completely contained within another. Equal sets, if A is equal to B, then A is a subset of B and B is a subset of A, okay? Why that keeps changing. Sets with some common elements. If set A and set B have at least one element in common, then the circles representing sets must overlap. Okay. So use the Venn diagram to determine each set. The universal set, let me see, A, B, C, D, E, F, G, H. So basically A through G. So this is going to be the set A, B, C, D, E, F, and G. So the curly brackets just means the set containing B. All the elements that are in B are basically regions 2 and 3. So that's going to be D and E. The set of elements in A but not in B. So that's going to be region 1. A, B, and C. And we see those results here. Okay. The set of elements in U that are not in B, so basically it's called B complement, is A through G excluding D and E. Right? So I'll abbreviate it like this. So it's A, B, C, F, and G. The set of elements in both A and B. So the parts common to both is going to be this region 2 here, which is just D. Okay. Okay. You have to forgive me. It's like 5 in the morning. I'm just waking up. So the complement of a set. Let me see. So the definition of a complement of a set, the complement of a set A symbolize, and also it's like, I bit my tongue, not my tongue, my lip in my sleep a couple of nights ago, and it's like every night it keeps getting like rebit. You know how like when you get a wound and it just keeps getting like reopened up, and I'm like, ugh. So that's part of the reason, like that's part of the struggle here. But anyway, the complement of set A symbolized by A prime is the set of all elements in a universal set that are not in A. This idea can be expressed in set builder notation as follows. So A complement is the set of all X such that X is in U, or the universal set, and X is not in A. Okay. So the shaded region represents the complement of set A, or A prime. This region lies outside the circle. So A complement is going to be everything that's in our universal set, but outside of the set in question. Okay, and in this instance, it's this dark blue shaded region here. That's A complement. Okay. So let the universal set be the counting numbers from 1 to 9, and let A be the set 1, 3, 4, 7. Find A complement. Okay, so A is 1, 3, 4, 7, and the universal set are the counting numbers from 1 to 9. So then A complement, or A prime, is going to be the set basically, and you can clearly see in the image to the right, 2, 5, 6, 8, 9. 2, 5, 6, 8, and 9. Okay. 2, 5, 6, 8, 9. Same. So what do we mean by the intersection of sets? The intersection of sets A and B, written A intersection B, is a set of elements common to both sets A and set B. This definition can be expressed in set builder notation as follows. So A intersection B is the set of all X such that X belongs to A and X belongs to B. All right, and I'm trying to highlight so you know what each symbol means and how to read this stuff. Okay. So again, essentially, intersection is going to be those elements that are common to both sets. Right. So find each of the following intersections. So we have in part A, we have these two sets. So then what do they have in common? I am going to highlight the common areas, right? So what do they have in common? Let's see. It looks like they both have 8. All right. It looks like they both have 10. And it looks like it. So I guess to be consistent. So their intersection is going to be just 8 and 10, it looks like. I'm just going to highlight it like this. What do these have in common? 2, 4, 6, 8. So their intersection is the empty set. They don't have anything in common. So it's the empty set or a 0 with a slash through it. What does this have in common with the empty set? Nothing. So we're going to say the empty set. So we got our 8, 10 and a double empty set. So we looked at intersection of sets. Now we want to look at union of sets. The union of sets A and B, written A union B, is a set of elements that are members of set A or set B, or both, right? This definition can be expressed in set builder notation as follows. A union B is the set of all X such that X belongs to A or X belongs to B. I think with intersection, instead of that being an or, it was and, right? And we were limited to only those elements that were common to both. With union, we're basically saying take all the elements of A and combine them with all the elements of B with no repeats. Okay. So find each of the following unions. Basically just put the two sets together. 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 12, right? So basically 6 through 12. 6, 7, 8, 9, 10, 11, and 12. Okay. 1, 2, so it's basically what, 1 through 9? Okay. 1, 2, 3, 4, 5, 6, 7, 8, and 9. We're just putting these two sets together. A set union, the empty set, is just going to be itself. 1, 3, 5, 7, and 9. And we just have a type version of what we just experienced. So then the empty set and intersection and union. For any set, let's see. So for any set what does a set have in common with the empty set? Nothing, right? So any set intersection the empty set is an empty set. Any set combined with the empty set is itself, right? Okay. So performing set operations. Some problems involve more than one set operation. The set notation specifies the order in which we perform these operations. Always begin by performing any operations inside parentheses. So given these three sets, we're asked to find A union B complement. So again, the recommendation is to start inside the parentheses. So first we're going to find A union B, then we're going to find the complement. Okay. So then let's see. Let's find A union B first. Let's see, 1, 3, 7, 9, or 1, 3, 7, 8, 9, 10. 1, 3, 7, 8, 9, and 10. Okay. So then A union B complement is going to be everything that's inside our universal set outside of this set. All right. So the universal sets are the counting numbers from 1 to 10. So then we want the counting numbers from 1 to 10 that are not in our set, right? So notice we skipped over 2, 4, 5, 6, and that's it, right? So let's get rid of this. So then A union B complement is going to be this guy here. 2, 4, 5, 6. 2, 4, 5, 6. Okay. We're moving and grooving. Okay. Not too bad. So given these sets, find A complement, intersection B complement. Okay, so we're going to break these down part by part, right? So first we're going to find A complement. That's going to be everything inside our universal set, but not in our set A. A universal set is going to be our counting numbers from 1 to 10. So then that means A complement is going to be what? Skip over 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right. B complement Same notion, same idea. So one or similar, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So then finally, A complement intersection B complement. Matter of fact, I'm just going to put it right here. All right, use the space. So I want to take the intersection of these two sets. So let me highlight what they have in common. It looks like they both have a 2. They both have the 4, 5, and the 6. All right, and I think that's it. Those are the elements that are common to both. Okay. So then A complement intersection B complement is going to be the set. Let me clean that up. And let me do this. Okay. So this is going to be the set 2, 4, 5, 6. 2, 4, 5, and 6. You can see the 2, 4, 5, 6 here. So use the diagram to determine each of the following sets. So then A union B, basically you're going to put all these outcomes together with the exception of the 666. Why did you use 666? That's fine. B is going to be what? A union B complement. Let me see. So A union B complement is everything that's inside our universal set, but outside of A union B. So that's just going to be region 4, which is going to be the 666. Okay. A intersection B is just going to be region 2. So that's just going to be this region here. Okay. A intersection B complement is everything that's in our universal set, but outside of region 2. All right, because region 2 is A intersection B. So then all the results you see remaining is what's going to be D. A complement intersection B, we should write that out. Basically for E, what we would do is find A complement first and then intersect that with B. Just for the sake of time, I'm just going to piggyback off of my prepared notes, right? A union B is basically regions 1, 2, and 3. You have the results here. A union B complement, it should just be the 666. You see it here. Region 4. A intersection B should just be region 2 here, right? And you can see it here, region 2. A intersection B complement is everything that's in U but outside of 2, right? So it should be regions 1, 3, and 4. You see it here, 1, 3, 4, and then those outcomes. A complement, so everything outside of A and inside of B. So that's only going to be region 3. Right, outside of A but inside of B is going to be just this region 3. You see it here. Okay. A union B complement. So B complement everything outside of B, and we want to combine A. So that's basically going to be everything except region 3. So it should be regions 1, 2, and 4. You see 1, 2, and 4 here, and here are the results. Okay. I feel like that's okay. So set operations and Venn diagrams provide precise ways of organizing, classifying, and describing the vast array of sets and subsets we encounter every day. Or refers to the union of sets and refers to the intersection of sets. Right? So, I mean, that's pretty straightforward. Or is union and is intersection. Okay. So the cardinal number of the union of two finite sets. So the cardinality of A union B is going to be the cardinality of A plus the cardinality of B minus the cardinality of A intersection B, right? So when we consider A union B, we're taking all the elements of A and combining them with all the elements of B. The trouble is if we just say the number of elements in A plus the number of elements in B, there are some elements that are counted twice, right? If A and B have any common elements, if we just did that, there are some elements that we would be counting twice or that are getting counted doubled. So that's why we have this additional part here to remove the intersection. So that way we can move one of those doubles. We can remove one of those doubles, right? Okay. So some of the results of the campus blood drive survey indicated that 490 students were willing to donate blood. 340 students were willing to help serve a free breakfast to blood donors, and 120 students were willing to do both. How many students were willing to donate blood or serve breakfast? Okay. I'd actually like to do this with a Venn diagram. I need some space. So I guess. Let me copy this. Paste. I'm going to paste one right here. Okay. And then I think I'm going to do my view as seamless. Okay. So what we're going to do here, we're going to create a Venn diagram. So let me start with the circle. Right. I feel like that's a decent size. Let's copy and paste. That's decent. Oh, undo. That's decent. Let's go ahead and do our universal set. So we need something like this. Okay. So now let's go back. Let's see. Some of the results of campus blood drive. We got students that are willing to donate blood. We'll serve a free breakfast, and then both. So I'll let D be for donate blood. Students that are willing to donate blood, we'll label that here. For the students that's willing to serve breakfast, I'm going to label that as B. We have our universal set. So this is about the blood drive, right? So now, when we're filling in Venn diagrams, the recommendation is work your way from the centermost portion and work your way out, right? So we want to, idealistically, we want to start with those students that are willing to do both, right? If we're filling in the Venn diagram. So it says 120 students were willing to do both, right? So we're going to put our 120 here, okay? Now we kind of work backwards. It says 340 students were willing to help serve free breakfast. So that means with inside the breakfast circle, it needs a total 340. So that means in that right-hand region, let me see. Hey Siri, what's 340 minus 120?
340 minus 120 is 220.
So that means in this region over here, we need to put 220, right? Because again, inside the circle B, that needs to total to 340, right? Okay. As far as willing to donate blood was 490. So then 490, 390, I guess it's 370 here. Because again, if the students that are willing to donate blood is 490, that means this circle needs to total to 490. Okay. And then there's one more. We need to get that final region outside of these two circles. Let me see. Some of the results of the campus drives indicated that 490 students were willing to, donate blood, serve free breakfast, and 120 were willing to do both. Okay, well, I don't think we can get the region outside the two circles right now. How many students were willing to donate blood or serve breakfast, right? So remember, or means that we're talking about union. So it's basically asking us to find D union B, right? Okay. So it says how many, so that means we're doing cardinality of D union B. Okay. So that's going to be the number of elements in D plus the number of elements in B minus the number of elements in D, nope, back up, in D intersection B, okay? So the number of elements in D, I think we said that was 490 plus the number of elements in B is 340 minus the intersection is 120. Hey Siri, what's 490 plus 340 minus 120?
490 plus 340 minus 120 is 710.
710. I feel like that's not too bad. Okay. Low-key want to be like, are there any questions? But obviously we're not live, so you know how to work on that. Okay. All right. All right. So we just completed section 2.3. I'll be loading sections 2.4 and 2.5 momentarily. And so for today, when we meet, you know, we'll do our best to get through section 2.3. At least by the end of the week, we just need to be finishing chapter 2, right? So you can either use my pre-recorded lectures, just make sure that you're getting your attendance credit, right? And you're submitting your assignments promptly with high marks. And then, you know, and then you can kind of chill, right? A little bit. All right. And so on that note, we're going to end the session here. And did my image stop? Oh no. Oh, is it this? Okay, maybe it's just this. Let me go live. Okay. Yeah, I think we're okay. Okay, so on that note, we're going to end the session here. And from one beautiful mind to another, have a wonderful day, guys. See you at 11 o'clock. Take care. Peace.